Hi, this is Riverd Audio, and it's time to talk about preamplifiers. I have received a question to describe what a preamplifier is doing and show it with the block diagrams. So to understand the process of what is happening inside a preamplifier and what makes a good preamplifier good, such as the Conrad Johnson GET preamp. Why does it have such big capacitors? Why it's so darn expensive? And what can we learn from it? Because what I'm going to show applies for basically every preamplifiers, and it's going to be a little bit different from what you ever heard, how they describe preamplifiers, because there's like a generic description of them, what you read, what's in a preamp, and that's it. But that's for other purposes. So my purpose for the description is strictly towards sound quality. What are the elements inside the preamplifier that affect the sound quality? And here, for the first talk, I'm going to have 3 talks. At this first talk, I'm going to show you the elements in the signal path. So this is the block diagram of a preamplifier, what it does with the signal. So basically, we start with the input jack. So that's where your signal enters. So basically, you hook up your sources to the preamplifier. And the first thing that's going to have a significant impact in the sound of that preamplifier, the sound that it produces, the sonic signature of the preamp, is the input jack. And then the input jack is connected to a wire that connects it to the selector switch. And I mark the wire as a separate block because that piece of wire is already introducing its character, its sonic character to the sound, and the quality of that wire is going to affect the sound at a noticeable, at a significant level. And yes, there are some of you who are saying, wow, the difference is really minimal. I can tell you guys that if your system is of the highest level, then changing just that piece or any piece that I'm showing here, if you do any changes there, it's going to affect the sound and you can hear it, and you don't have to be a very experienced golden ear to hear it. Anyone can hear it, even if you are a non-audiophile. People tend to hear easily just a change in the wire when it's listened to at a very high level system. And my channel is really about getting the highest level of audio. I'm not BSing around with really low level junk stuff that's really prevalent in audio today. I'm really shooting for the very highest level in sound reproduction that you can achieve for yourself in your home. And when that's your goal, that's the level where you are at now, this is how things look like. And and when you see in the block that I said wire or trace, and that's because in most preamplifiers, commercial ones at least, you see that the input jack is wired, or any of the elements, most of the elements are wired through traces, through circuit board. So if you see a circuit board, then the connection between the elements will be the trace, that piece of copper, that edged copper that's on your circuit board. And that's the worst of the lot. So basically, when you have a circuit board trace, that's like using a poorest quality wire, and hardwiring your components is a major step up, because using that low level junk copper, now you have the chance to introduce some quality metal into your signal. And how does it impact the sound? Well, you have noticed that when you upgrade your interconnect cables, you upgrade your speaker cable, power cords, there's a major difference in the sound. Well, the same thing is also true for inside your components. So if you upgrade the junk connectors inside your component, there's a giant increase in sound quality. Usually people observe that in loudspeakers. When you upgrade the internal cabling, internal wiring of a loudspeaker, there's a major jump in sound quality. And this is also true for circuit boards. If you can bypass the traces, get rid of them, and do hard wiring, there's a huge jump in the sound. And that's what my mentor Stu did, and what I showed on the PV12 preamp that he modified is that he was bypassing the traces with hard wires, and that improved the sound just tremendously. But this is true for the GET preamp as well. It has loads of traces, and if you bypass it, you can still elevate the level quite a bit. So basically, the function of the selector switch is to give the ability to choose inputs. So you can have multiple digital sources, you can have a phono stage going in, and so on and so on. And then the selector switch selects your input, and then it continues through another wire or trace to the volume control. And the volume control, it can be different kinds. I'm not talking about that now. Time is too short for that. But then the signal goes from the volume control through another wire or trace to the gain stage. Now this is the heart of the preamplifier, the gain stage. So this amplifies the signal. So far what we had, everything is passive. And now this is the active part of the preamp. So basically, if a preamplifier has a gain stage, then it's an active preamplifier. If there's no gain stage, only input jack, selector switches, and then the volume control, then it's a passive preamplifier. So this is the heart, this is the key that differentiates active and passive preamps. So after the gain stage, we have another wire or trace, and then a decoupling mechanism that removes the DC bias from the signal, the DC component from the signal, and then in most cases that's the capacitor, that's the output capacitor, and then there's another wire or trace that connects to the output jack. And now here's your signal going to your amplifier. Also here I did not show one more thing, that the decoupling stage, it's not just a decoupling capacitor, but there's also a resistor as well that sets the output impedance of the preamplifier. I just mentioned it here now so you know what's happening, and the resistor after that decoupling capacitor, that's the that defines the output impedance of your unit. And if you don't know what it is, you can measure it, what's the value of that resistor, and then you can tell that's the output impedance of your unit. That was just a curio that I mentioned that's tangential to our subject today. So basically this is the basic signal path for every active preamplifier. Now for the exact applications, it can get more complex than this. So this is just the simplest thing. So this is what happens when you have a preamplifier with a single active gain stage and there's no EQ in it, no built-in EQ. And this is just the simplest, the absolute minimum. And when and as you see, we have still a giant, a vast array of units, internal blocks, basically, inside the preamplifier that impact the sound, affect the sound. And I can tell you guys, none of these has the ability to improve the sound all of these have only one potential towards the information that's coming from the source. It degrades the information, and by through two mechanisms or three. One of them is by losing some of the signal that's coming in, and the other is transforming the signal, changing it, and we call that traditional distortion. And the third is adding noise. So these three things can happen inside a preamplifier to the signal, and what we have to do, what makes a preamplifier a very good preamplifier, is that it does all of these three things to an absolutely minimal level. Now, if we use the least complexity, then we lose the least amount of information. But we have limitations as well, lots of limitations. And basically, when you have an absolute minimal preamplifier layout, then every other part of your audio chain has to match it perfectly. The gain structure has to mirror it perfectly. So such a unit mandates absolute system synergy from the rest of the audio equipment. And what we see at the commercial level is just virtually zero level of synergy. Things are really hodgepodge, mix and match. People are just making the parameters, the operating conditions of units to basically adhere to the absolute lowest common denominator. So they make things to be as universal as possible, so that you will buy that product regardless of the amplifier and the source you have. And that entails tremendous, horrendous compromises as far as the absolute potential of the equipment is. So basically, at any price range, whatever you are buying has a giant limitations built into them, because they have to make the units compatible to a vast array of stuff out there. And that brings about the necessity to add much more of these stages, to add multiple gain stages, add negative feedback. And why do people add negative feedback? It's one main reason is to get rid of all of the nasties that the lower quality units contribute to the sound. So if we are talking about PCBs, traces, circuit boards, then that's already a big thing that degrades the sound. So people install negative feedback to just shove and everything under the carpet. But when you add a lot of negative feedback, then you need to add additional gain stages, because negative feedback eats up the gain of the units. So that in basically almost every single preamplifier on the market, there are multiple gain stages. So basically this thing like the wire gain stage, wire decoupling, this unit is at least twice or three times and maybe four times in certain units in every single preamp on the market. And basically if you have like three of these blocks, then basically we have already doubled the number of units that transform and alter the sound. But commercially they are telling you that negative feedback is going to fix everything. No, it's not fixing everything. It's making adding a tons of its own spices and like a spice blend, and creates a hamburger mix from your fine steak. So whenever you add negative feedback, it just brings everything to a certain sound. And that's why I don't like that thing that negative feedbacks does to the sound, because it always brings with it the absolute destruction of the finest level of signals. And yeah, so that's something that is there when you see negative feedback employed. It's always put in the preamplifier to uh, counterbalance the negatives of these blocks inside the unit. And usually, as you see here, this is like a minimalist system. So in these cases, people don't employ negative feedback, or when they do, they make it because they want to lower the output impedance of the unit to be able to drive very difficult to drive amplifiers. But this is not the topic for today. But when such a simple approach requires negative feedback, it's to make the unit compatible with all the junk stuff on the market. And if you have a system where one unit is matched perfectly to the next, so basically your preamp is matched perfectly to your power amplifier, then you do not need negative feedback here. So what else do I want to add? Nothing. We are done for today. And oh, one more thing that I want to add is the EQ. So why is it so that audiophile gear do not have equalization built into them? It's because when we add an EQ circuit, so you can change the bass, the treble, or maybe even the mid-range, and you can even change the balance. If you want to add this, that adds more building blocks to the preamp than what you see here. So basically the ability to control the EQ doubles the units in the preamplifier that degrade the sound. And as you see, that's why it's not employed, because the degradation it brings about is tremendous. And the reason for that is that when we use EQ, it also requires adding multiple gain stages, because all the elements, the ability to boost bass level, to boost the treble, it requires a gain stage to do it, or actually multiple gain stages. And with that comes the terrible drop in sound quality. Basically, each gain stage you add, there's a marked drop in the maximum potential that you can get out of the sound. And even if you have a very high level unit like the CJ GAT preamplifier, an EQ is just dropping the sound quality. So without EQ, you have a very high level of sound, and adding it just brings it down to the level of couple levels lower. So thank you guys for listening to this explanation on how preamplifiers work, and we will continue the next time with the power supply, because this was just the signal path part of the preamplifier. I will have one more talk on how the power supply building blocks are, and a third talk on the gain stage. So what is inside a gain stage? Because you see here it just says gain stage, but basically when we look what's in it, it's a myriad components as well. So thank you guys, please like and subscribe. Have a wonderful day. Bye bye.